Welcome to a lesson with Dr. Powell. Let's take a look at some other identities which will be important for us to be familiar with. First, let's take a look at cosine of A plus B. What is this? There's a nice formula for this one, cosine A, cosine B minus sine A, sine B. Now this actually has a really nice derivation if you think about complex numbers and multiplication. And it has to do with if you have two angles, or let's think you have an angle A, and you can represent this if you think about the y as being like an imaginary part, the x as being a real part, then this could be thought of something like cosine A plus I times sine A, where this is like the y coordinate, that's the x coordinate. You can think of it as a complex number if you wanted to. And similarly, if you had one for B, it would be the same thing. Now, what happens when you multiply two complex numbers together that are on the unit circle like this? Actually, what happens is it just rotates to the sum of the two angles. And that could be, you'd have to go back and study that in order to be convinced of that fact. But nonetheless, multiplying on the unit circle just adds angles. So keeping that, if we multiply this complex number by the complex number for angle B, so cosine B plus I sine B, look what happens. The cosine of the sum, or the cosine of this, the cosine of A plus B is actually going to be the real part, because this is going to rotate right to the place where you add the two angles. And so the cosine is going to be the real part of this. How do you get the real part? Well, you're going to get the imaginary part by when we do a FOIL on this. Let's see, when we do a FOIL, this is what we'd call the F of the FOIL, the first. The O is the outsides. The I is the insides, and the L is the outsides. Or not the last. I mean, the L is the last. Okay, is what I meant to say. Yeah, inside and then last. Notice that the real part is going to be just made up of the first and the last, because when we multiply this times this, we're going to have an I times I, which is a -1. Notice that's exactly how this came about. Cosine A times cosine B minus sine A times sine B, just right there. So we should be able to write down this formula as well, sine of A plus B. What is that? So sine of A plus B would just be the imaginary part of this, but we're going to just ignore the I. So that's actually the I plus the O where we're ignoring the I. Notice that's going to be, and you can do this in any order you want, but basically sine A, to I first, sine A cosine B plus, and then here we have, you can do cosine A sine B, or however you want to do it right there. Okay, so basically you have the sine and cosine, these are the A and B's are just switching places what they're going into. Okay, so we got these two very nice identities. Now, where are we going to be using these most of the time is actually when A and B are the exact same. So when A and B are the exact same, so perhaps they're both x, so that's x plus x, or maybe just 2x. Cosine of 2x, and that's going to be cosine x times cosine x, which is cosine squared x. And what is that? That's like minus sine squared x. Now, similarly over here, what would this be? So of 2x, so A and B are both x. That would be the same thing as sine x, cosine x, sine x. Basically, these are the same. It's just 2. It's just double. So 2 sine x, cosine x. So this is an important identity. And this is an important identity. but we can actually add to that list a little bit. Let's take a look at this one right here and explore this one a little bit more. That's something actually we'll be using quite a bit. So let's take a look at that. So remember what that is. So we have cosine of 2x is equal to cosine squared x minus sine squared x. Let's use a Pythagorean identity on this guy right here. 1 minus cosine squared x, because cosine squared plus sine squared is equal to 1. So if we say 1 minus cosine squared, you're going to get sine squared. So cosine squared x is equal to cosine 2x. And then notice you're going to get minus minus as an addition here when you distribute that, minus a 1. So we're going to get 2 cosine squared x minus 1 is equal to cosine 2x. Now if we add 1, divide by 2, so 1 plus cosine 2x over 2, that is cosine squared. Now, with integration and other things, this is an important identity which we will be using. If we say a cosine squared, we can think of it as 1 plus cosine 2x over 2. This will be nicer to work with for us to translate this into that. So this is an important identity. Now notice how I converted all of this to cosine squareds. I could have similarly converted everything to sine squareds instead. See this cosine squared, I could have rewritten it as sine squared by replacing it with 1 minus sine squared. But then I still have that minus sine squared there. So this side would become 1 minus 2 sine squared x. So then if I multiplied both sides by -1, we'd end up getting negative cosine. Let's see here. Let's rewrite like here. So negative cosine 2x is equal to 2 sine squared x minus 1. Then if we add 1, so 1 minus cosine 2x, and then divide by 2, we get a nice other identity, which we will be using often right here. So sine squared x is the same as 1 minus cosine 2x, all divided by 2. So using these two identities will be very valuable. So keep these in mind as we go along. Thanks for watching.